Imagine walking into your annual performance review, right? You sit down across from your manager and they just look at you and say, well, your bonus for the entire year has just been calculated by a random number generator.
Yeah, that sounds terrifying.
Right. Like Monday, it might be $10,000. And Tuesday, it might literally be zero. And it all depends on this invisible, like, temperature setting of a black box algorithm.
Which is just wild to even think about in a corporate setting.
It is. But here's the thing. Millions of customer service agents across the enterprise world right now, that completely absurd scenario is rapidly becoming a reality.
Unfortunately, yeah, it really is.
And it is all because of this massive architectural trap that the TAD industry is just like falling into headfirst right now. The large language model wrapper.
The infamous wrapper.
Exactly. We're taking these massive, highly sensitive data problems, like evaluating how well a human being actually does their job, and we're just tossing them at a single generic generative AI.
And expecting it to function with the precision of a scalpel, which, is just the fundamental misunderstanding of what a generative model actually is.
Right, because we see an AI like write us a stunningly beautiful sonnet or summarize a dense 50-page financial report in 3 seconds. And we mistake that linguistic fluency for universal competence.
Yes. We assume that if it can talk like an expert, it must be able to calculate and measure and, judge like an expert.
Yeah.
But in the realm of enterprise software, fluency is entirely separate from precision.
Okay, let's unpack this for you because that distinction is huge.
It really is. Think about it like this. If you decide to build a house, you don't hand your general contractor a Swiss Army knife.
I hope not.
Right. Like, sure, it has a sawed, it has a blade, a screwdriver. It is the ultimate versatile tool.
Mm-hmm.
But you absolutely cannot use it to run the electrical wiring or frame the roof.
You need specialized tools for that.
Exactly. Versatility actually becomes a massive liability when the job requires specialized deterministic tools.
And that distinction between the Swiss Army knife and the master carpenter's tool belt, that is the absolute core of our deep dive today.
Yes, it's so important.
We are exploring this fascinating, highly technical architectural breakdown from SupportLogic. It's a piece titled Beyond LLMs, Why AutoQA Requires a Multi-Model ML Architecture, and it was written by K.S. Uthaya, their Director of Product Management for Engineering, published back in March of 2026.
It's a brilliant piece of engineering literature, honestly.
It really is. So our mission for you today is to completely deconstruct why piping your customer support data directly into a generic tool like a ChatGPT or a Gemini is just a massive recipe for operational disaster.
A total disaster.
Yeah. And more importantly, we are going to look at the anatomy of what actually works. We're going to explore how specialized models just drastically outperform generic LLMs for scoring and math.
Which they do, hands down.
Right. And we'll look at why this improves quality assurance for enterprise support leaders and how a truly modular multi-model architecture is constructed.
Because, the stakes here go far beyond just buying the right software. We are talking about AutoQA, automated quality assurance.
Right. This isn't just a chat bot.
Exactly. This isn't a customer-facing bot where a hallucinated answer just leads to a confused user.
Mm-hmm.
These are internal systems that generate defensible, auditable metrics.
The metrics that actually affect people's lives.
Yeah. These metrics determine if a customer support agent is adhering to strict corporate policies, whether they're effectively resolving issues, and ultimately whether they get promoted or fired.
Wow. Yeah, that's heavy.
When an AI evaluates human performance, the tolerance for error just drops to absolute zero. Knowledge is only valuable when applied correctly.
So let's look at the actual parameters of that job. If we're trying to replace manual, human-driven quality assurance with an automated system, what is the software actually required to evaluate? Because we're not just asking, was the customer happy?
Oh, far from it.
Yeah.
It's so much deeper than that. The source details that the AutoQA system is responsible for evaluating 13 distinct agent behaviors.
13? That's a lot to track.
It is. And we are looking at deeply nuanced actions, right?
Mm-hmm.
Like, did the agent use the proper greeting? Did they demonstrate active listening?
Right.
Did they ask the right probing questions to diagnose a complex technical issue? Did they successfully resolve the ticket? Did they adhere to the service level agreement, the SLA?
And they have to do this across different formats too, right?
Exactly. The system has to measure these behaviors across multiple modalities, meaning both text-based chats and voice calls.
Oh, wow.
Yeah, while simultaneously tracking the chronological flow of the interaction over time.
See, from the outside looking in, if I'm an enterprise leader who just watched a demo of GPT-4 passing the bar exam and writing functional Python scripts,
Yeah.
I would immediately think, just feed the call transcript into the LLM and ask it if the agent was polite.
Right. It feels like a completely solved problem.
Yeah, like the AI has read the entire internet. Surely it can grade a 5-minute customer service interaction.
Wow.
Why not just use an LLM?
Well, the logic seems sound until you look under the hood of how these models operate at scale. The source actually refers to this approach as the wrapper reckoning.
The wrapper reckoning, I love that term.
It's very fitting. Building an LLM wrapper essentially means you are just using a commercial LLM as your entire backend. You take your data, paste it into a prompt, ask your question, and display the AI's response in your user interface.
Seems simple enough.
Too simple. The text outlines 6 fatal flaws with this approach for enterprise QA. Let's start with the most glaring physical limitation, which is the modality gap. LLMs are, by their very nature, completely deaf.
Deaf, meaning like they only ingest the text, they're looking at the words on a page, the transcript of the audio, but they are entirely missing the acoustic delivery of those words.
That is the absolute crux of the issue. I mean, think about how much human communication relies on tone alone.
Oh, yeah. Huge amount.
A transcript might show the agent saying, "Take your time, I am happy to wait while you pull up that account number."
Which sounds lovely in text.
Right. In text, that reads as perfectly empathetic and patient. But if the agent delivered that exact same line with a heavy sigh, speaking rapidly through gritted teeth, the actual meaning is the exact opposite.
Right, it conveys deep frustration, sarcasm even.
Exactly. An LLM reading a plain text transcript has zero access to that acoustic signal. The modality gap means the emotion is completely lost in translation.
You lose the music of the conversation. And in a high-stress environment like customer support, the music is often way more important than the lyrics.
Beautifully put, yes.
Okay, so they can't hear tone. That's flaw number one. But what about the rigid business rules? Like, let's say we are evaluating response times.
That brings us to the second massive failure point, arithmetic failure. Evaluating response times usually involves calculating SLA adherence.
The service level agreement.
Right. A service level agreement dictates that an agent must, for example, respond to a high priority ticket within 15 minutes.
Okay, simple enough.
To grade that, the system must calculate the difference between the timestamp of the customer's message and the timestamp of the agent's reply.
Which is just basic math. But an LLM isn't a calculator, right? It's a prediction engine.
Exactly the problem.
Yeah.
When you ask an LLM to evaluate if a 28-minute response violates a 15-minute SLA, you are forcing it to do math using natural language prediction.
Oh, man. So it's not actually subtracting.
No, not at all. It's looking at the tokens, chunks of words and numbers, and trying to guess the statistically most likely next token based on its training data.
Right.
It is not fundamentally computing the difference between two integers.
I think of it like asking a brilliant poet to do your corporate taxes.
That's a great way to look at it.
Right. Like the poet might write a beautiful sweeping narrative about the passage of time and the burden of financial responsibility and the conceptual weight of numbers. But when you look at the actual sum at the bottom of the ledger, the math is going to be completely wrong. You need a spreadsheet, not a sonnet.
That is a perfect analogy. The models simply fail at deterministic computation. And the downstream effect of a model guessing rather than calculating leads to the third major flaw, toxic hallucinations.
Hallucinations. The classic LLM problem.
The worst one. LLMs are famous for hallucinating, which is when they generate false information with absolute confidence.
And the source has a really specific example of this, right?
It does. The text details a specific scenario where an LLM wrapper was asked to summarize an agent's weekly performance. Because the context window was sparse, like maybe the agent hadn't taken many calls that week. The LLM just invented a trend.
You just make something up.
It stated, grammar is a recurring issue for this agent.
Even though the raw data showed absolutely zero grammatical errors.
Exactly. The AI just filled dead air or the plausible sounding critique.
And in a coaching environment, fabricating a performance issue is just operational poison.
It's incredibly toxic.
I mean, if a manager brings an agent into a coaching session and reprimands them for a grammar issue that never even happened, you don't just lose that one coaching session. You permanently destroy that agent's trust in the entire QA program, and probably their trust in their manager, too.
Absolutely. You lose the employee.
Think about it for you, the listener. If your boss accused you of constantly showing up late, when you knew for a fact you were early every single day, you'd immediately assume the system was broken or your boss was just out to get you.
You would never take another piece of feedback seriously.
Never. That is a massive liability. And it ties directly into the fourth issue outlined in the text, non-determinism. This goes back to that random number generator concept I mentioned at the start.
Yes, non-determinism is the absolute enemy of enterprise software. LLMs are stochastic.
And for anyone who might not build these systems daily, stochastic simply means what exactly?
It just means there is an element of randomness injected into how the model selects its next word. It's what makes the AI sound creative and human.
Right, which is great for writing a story, but
if you feed the exact same transcript into an LLM and ask for a QA score out of 100, you might get an 85 on Monday morning. Run the exact same prompt on Tuesday afternoon, and you might get an 81.
the input doesn't change, but the output does, which completely obliterates any concept of an audit trail.
Completely.
If HR is using these scores to determine promotions or manage performance improvement plans, the scoring mechanism has to be rock solid and reproducible. You cannot tell an employee they missed their bonus because the neural network happened to run a little cold that day.
You would be opening the company up to incredible internal friction and, potentially massive labor disputes. The score must be immutable.
So that's 4 flaws. What's number 5?
Then we move from the structural flaws to the harsh reality of cloud economics. Flaw number 5 is cost.
Always comes down to the money.
Always. The source explicitly mentions a strict budget constraint. AutoQA systems often need to operate at a cost of less than $1 per customer case.
Less than $1. Which, it doesn't sound like a lot until you multiply it by enterprise volume. A major contact center might handle, 50,000 tickets a day?
Easily. And remember the complexity of the task we talked about earlier. We aren't just asking one question. We are evaluating 13 distinct behaviors.
Oh, right.
So if you are using a frontier-level LLM wrapper, you're sending a massive payload of text, thousands of input tokens to the API, asking it to evaluate behavior 1. Then you send it again for behavior 2.
Wait, you have to send the whole transcript every time.
In many wrapper setups, yes. Or you risk losing context. So if you loop a massive LLM 13 times per ticket, you will blow past that $1 budget constraint almost immediately.
The compute alone would bankrupt the project.
Exactly. The cost per case math simply does not support using an LLM as a universal classifier at enterprise scale.
That brings us to the final nail in the wrapper's coffin, flaw number 6. False positive asymmetry. I find this one fascinating because it really gets into the psychology of how we manage people.
It does. It's very psychological. LLMs have their own internal, pre-trained sense of what constitutes negative sentiment, but they lack tunable, granular thresholds.
What does that mean in practice?
In customer support QA, you are constantly balancing false positives against false negatives. A false negative means the AI missed a bad interaction, like the agent was rude and the AI didn't catch it.
Okay, and a false positive.
A false positive means the AI incorrectly flagged a perfectly good interaction, unjustly penalizing the agent.
And the cost of those two errors is not equal at all.
Not at all. Missing a rude interaction is unfortunate, yes, but unjustly punishing an innocent agent erodes the entire foundation of your workforce. The asymmetry means you need extreme control over the strictness of your models.
Right, you need a dial.
Exactly. You need to be able to tell the system, only flag this if you are 95% certain. Generic LLMs require incredibly convoluted prompt engineering to even approach that level of fine-tuning, and even then, it is highly fragile and prone to breaking.
Wow, okay. Looking at all 6 of those flaws together, it paints a pretty bleak picture for the wrapper approach.
It really does.
I mean, the Swiss Army knife approach cannot hear tone, it cannot do math, it hallucinates fake feedback, it provides inconsistent scores, it costs an absolute fortune, and it accuses innocent agents of making mistakes.
Which is exactly why the engineering team at SupportLogic abandoned the wrapper approach entirely. If you want precision, you have to build a toolkit. You need a highly structured multi-model ML architecture where specialized tools handle specialized tasks.
So let's tear down that architecture and look at the blueprints. Let's really get into the weeds here. The source outlines a deeply modular system built in layers. Let's start at the foundation with layer 1 and layer 2. The specialists.
The specialists, I like that.
Right. Their entire philosophy here is division of labor. Keep the LLM away from the raw data and let specialized, narrow models do the heavy lifting of classification and measurement.
Yes. Layer 1 focuses entirely on pre-processing the raw interaction. Before you can evaluate anyone's behavior, the system has to organize the sheer chaos of a real-world conversation.
And how do they do that?
They begin with speaker diarization.
Okay, for those of us unfamiliar, diarization is simply the technology that splits the audio file into separate tracks, right?
Correct. It identifies exactly when the customer is speaking and when the agent is speaking, even if they are interrupting or talking over each other.
Which is crucial because if the AI accidentally grades the customer's behavior instead of the agent's, the whole system collapses.
Precisely. You'd be firing an agent because the customer was yelling.
Exactly.
Once the speakers are isolated, they run sentiment detection. But this is where they solve that modality gap we discussed earlier. They don't just analyze the text transcript. They deploy a dedicated acoustic tonality model.
A model that actually listens to the sound.
Yes. And what's fascinating here is the infrastructure behind it. The source notes that this specific acoustic model is hosted on a dedicated Vertex AI endpoint.
Oh, I caught that in the text too. Why call that out? Like, what's the advantage of putting it there instead of just running it on their standard infrastructure?
It comes down to processing heavy continuous streams of data. Vertex AI allows the engineering team to configure larger payload capacities and longer timeout thresholds.
Because audio files are huge compared to text.
Audio processing is incredibly resource intensive. If you use a shared generic infrastructure, the connection might literally time out before a 30-minute audio file finishes processing. A dedicated endpoint ensures the stability required for that massive enterprise volume.
That makes total sense. But the way the model actually listens to the audio is what really caught my attention. It doesn't just listen to the whole 30-minute call and give a summary at the end.
No, that would be too muddy.
Right. It extracts and analyzes microslices of audio specifically, 3-second chunks of only the agent's speaking intervals.
The granularity there is entirely intentional. Think about it. Human emotion, particularly in a tense customer service scenario, it isn't static. An agent might be perfectly calm for 20 minutes, and then for 10 seconds, their frustration just leaks out into their tone of voice.
Yeah.
By isolating the audio into 3-second windows, the system can pinpoint the exact moment the acoustic signal shifts.
It's like scanning for a spike on a monitor.
Exactly. And they are scanning for a very specific negative signal. Agent anger.
And just to be clear, they are looking for agent anger, not customer anger. Like we said, customers are allowed to be angry. They are calling customer support because something is broken.
Right. Customer anger is expected.
But if the agent gets angry, that's a massive process failure. Now, the document mentions something interesting. It says that the underlying model is technically capable of tracking 7 different emotional states, right?
It is. Angry, disgust, fearful, happy, neutral, sad, and surprised.
But the engineers deliberately chose to ignore almost all of them. They only use angry. Why leave so much data on the table? If an agent sounds sad or disgusted, isn't that valuable information for a manager to have?
It seems like valuable information until you run it through rigorous testing and look at the data noise it creates. What's fascinating here is the AI fairness aspect. The engineering team discovered that the model's classifications for several of those emotions were highly inaccurate in real-world environments.
Inaccurate how?
Well, for example, the model disproportionately flagged certain thick accents or regional speech patterns as disgust.
Wait, really? Because of an accent?
Yes, because the phonetic structure of certain vowels or consonants triggered the acoustic markers the model associated with a disgusted tone.
So the acoustic shape of the accent actually confused the model.
It did. If they had allowed disgust to remain as a scoring metric, the system would be flooded with false positives. It would generate noisy, inaccurate data that systematically downgraded the scores of agents with specific accents.
Which is terribly unfair.
It was a massive AI fairness and accuracy failure. Furthermore, the model struggled to differentiate between fearful or sad speech and voices that simply had a naturally low amplitude.
Meaning people who just naturally speak softly or quietly.
Exactly.
So a soft-spoken agent gets flagged as sad, and an agent with the specific accent gets flagged as disgusted. That doesn't just make the system unfair, it makes the data completely useless to a QA manager.
Exactly. When building a precision tool, noisy data is worse than no data at all. So the engineering team made a deliberate choice to ruthlessly prune the signals. They stripped it down to the highest confidence metric, anger.
Wow, that takes discipline.
And even then, they gate the classification behind a strict confidence threshold. If the system is only 60% sure it heard anger, it defaults to neutral.
It errs on the side of the agent.
Yes. This is the exact kind of rigorous, data-driven engineering decision that is impossible to implement if you are just blindly trusting an off-the-shelf LLM wrapper.
That perfectly illustrates the difference between deploying AI as a shiny novelty and deploying it as actual industrial infrastructure. You have to aggressively filter out the noise.
You really do.
So, Layer 1 has conquered the audio gap. We know who is speaking, and we have a high confidence read on their acoustic tone. Now the data moves up to Layer 2, behavior classification. This is where the actual text transcript gets analyzed to answer those 13 behavioral questions.
Right. And this layer relies heavily on a model called Roberta Base.
Roberta.
Yes. And Roberta is not a generative model. It doesn't write poetry or chat with you. It's a highly optimized model, fine-tuned specifically for discriminative tasks.
Discriminative meaning it is designed to categorize or classify data into specific buckets rather than generating new text from scratch.
Correct. It answers binary yes or no questions with extreme mathematical confidence. Did the agent acknowledge the customer's core issue? Yes or no? Did the agent offer additional assistance before closing the ticket? Yes or no?
So it's just very focused, very narrow.
Roberta is the workhorse here. It scans the text to identify these complex semantic behaviors. And it operates at different scopes depending on the behavior. Determining if an agent showed empathy might only require analyzing a single sentence.
Okay, that makes sense.
But determining if the agent reached a successful resolution requires Roberta to hold the entire context of the ticket in its memory and evaluate the final outcome.
Which is a much heavier lift. But even with a powerful classifier like Roberta, the source reveals that the team doesn't use neural networks for everything. And this leads us to one of the most elegant parts of the entire architecture, the spacey rule-based engine.
Yes, spacey.
Spacey is completely different from a neural network, right?
Radically different. Spacey, in this context, is used as a deterministic linguistic pattern detector. It is entirely rule-based. The underlying philosophy here is vital for any engineering team to understand. Do not introduce model uncertainty where absolute certainty is achievable.
I love that. Let's test that logic, though. If a QA manager wants to know if the agent used an appropriate opening greeting, how does Spacey handle that compared to a neural network?
Well, a neural network would process the text, weigh the semantic embeddings of the words, calculate probabilities, and eventually predict whether a greeting occurred.
It's guessing based on math.
It's a massive amount of computational power applied to a very simple problem, and it still carries a slight margin of error. Spacey, on the other hand, operates more like an incredibly advanced version of the find function on your computer.
Oh, like CRLF.
Exactly. The engineers write explicit deterministic rules. They tell the system to look for specific structural patterns. Hello, welcome to, thank you for calling. If the pattern is present, the rule fires. If it's not, it doesn't.
It either is or it isn't. Zero ambiguity.
And the operational advantage of that is profound auditability.
Because you can actually see why it flagged it.
Right. If a ticket gets flagged because an agent missed their greeting and the agent disputes it, the QA lead doesn't have to guess what a black box AI was thinking. They can look directly at the Spacey rule. They can read the exact logic.
Oh, that's huge.
And think about updates. If the company introduces a brand new mandatory greeting tomorrow, say, Happy Holidays from support, the engineers just add a line of text to the rule. They don't have to gather 10,000 examples of the new greeting and retrain a massive machine learning model.
So for rigid pattern-based behaviors, a rule-based engine drastically outperforms AI in speed, reliability, and interpretability.
Absolutely.
It is incredibly refreshing to see a cutting-edge engineering document effectively say, you know what, we don't need AI for this specific part. A basic airtight rule works much better.
It shows a level of discipline that is often really missing in the current hype cycle.
It really does. Okay, let's take stock of where we are. We have processed the raw audio. We have filtered out the noisy data to find true acoustic anger. Roberta has semantically classified the complex behaviors. Spacey has rigorously checked the linguistic patterns. We have all these individual data points.
A lot of data points.
But we still don't have a final grade, right? We don't have that 85 out of 100 that goes on the agent's performance review. To get that, we have to move to layer 3.
Yes, layer 3 is the deterministic scoring layer. And the source document draws a math red line here. In layer 3, neural networks and generative AI are completely banished.
Banished entirely.
The actual computation of the score is handled exclusively by deterministic Python scripts.
The spreadsheets take over. We have finally fired the poet who was trying to do our taxes.
We have. Let's return to the service level agreement example. SLA adherence is a pure mathematical computation. The SLA dictates a response must occur in under 15 minutes.
Right.
The customer emailed at 1:00 p.m. The agent replied at 1:12 p.m. The Python script calculates the difference. 12 minutes. 12 is less than 15. The behavior is marked as a pass.
So clean.
There is absolutely no nuance required, no semantic context to interpret. The system's absolute guiding principle, as stated in the text, is we do not let the LLM do the math.
I feel like we do not let LLM do the math should be like the foundational mantra for anyone building enterprise software right now.
I would buy that on a t-shirt.
Me too. So the Python scripts take the classifications from layer 2, apply the specific mathematical weights that the business has decided on. Maybe resolution is worth 50% of the grade and empathy is worth 20%. And it calculates the final immutable numeric score.
Yes. And if we connect this to the bigger picture, the mechanical reason for designing it this way reveals the true power of a multi-model approach. Extreme modularity.
Modularity. Break that down for me. If I'm an enterprise support leader listening to this, how does that modularity actually impact my day-to-day operations?
Well, think about how rapidly a business changes its priorities. Imagine it's the start of a new fiscal year. The executive team decides that customer retention is the ultimate goal now, so they want empathy and active listening to be weighted much more heavily in the QA rubric.
Okay, pretty common scenario.
If your system is one massive LLM wrapper, changing the grading rubric requires you to completely rewrite your master prompt. You have to try to explain the new mathematical weighting to the language model.
Which sounds like a nightmare.
It is. And when you do that, you risk accidentally breaking how the model understands completely unrelated concepts, like how it identifies a resolution. It's a fragile house of cards.
Because tweaking one part of a massive prompt often causes these unpredictable ripple effects across the entire output.
Exactly. But with SupportLogic's modular design, the neural networks aren't involved in the weighting at all. To change the rubric, an administrator simply updates the parameters in the deterministic Python script.
And it just works.
The math changes instantly and flawlessly, while Roberta continues classifying text exactly as it always has. Furthermore, it future-proofs the entire platform against the relentless pace of AI development.
How so?
If a revolutionary new LLM is released tomorrow that is twice as fast and half the cost, the engineering team can swap out the LLM in layer 4 without ever worrying that it will accidentally alter how an 85% is calculated in layer 3. The integrity of the score is mathematically insulated from the shifting landscape of generative AI.
Oh, wow. So for anyone listening who is currently in the market to buy or build an AI evaluation system, this modularity is really the hidden feature. It's what determines whether your massive software investment survives the next 3 years.
Absolutely.
If you buy a monolithic LLM wrapper, you are locked into a fixed appliance that will inevitably degrade. If you invest in a decoupled modular infrastructure, you have a living system that adapts without breaking.
It is the architectural difference between building a sandcastle and building a skyscraper with a steel frame.
I love that. So we have built the steel frame, we have the audio processed, the classifications made, the rules checked, and an airtight, mathematically unassailable score calculated in Python.
Yes.
We finally have a trustworthy, deterministic outcome. Now, and only now, do we invite the generative AI into the room. We move to layer 4, the generative synthesis layer.
This is where the large language model finally enters the pipeline.
Finally.
The SupportLogic architecture uses a specific model here, GPT 4.1 Mini, but its role is strictly constrained. It is not asked to calculate metrics, and it is not asked to judge the agent.
So what does it actually do?
Its sole purpose is to narrate. It acts as the translation layer, taking the hard pre-computed data from layer 3 and synthesizing it into highly readable natural language explanations for the human users.
Ah, so it's the communicator.
Exactly. It acts as the voice of the quality agent, summarizing the overall interaction, and the coaching agent, providing specific, actionable feedback to the employee.
The source outlines a very specific engineering decision here regarding how they feed data to the LLM. They use what they call a single-pass architecture. Why is that important?
It is entirely about surviving the brutal economics of cloud compute. Generating the narrative for the quality overview and the separate guidance for the coaching overview requires sending the LLM an immense amount of context.
Like everything we just talked about.
Yes. You have to send the entire transcript, the acoustic data, all the layer 2 classifications, the final Python scores, and the historical trends of that specific agent.
Which is thousands and thousands of input tokens for every single ticket.
Precisely. If you design the system to make 2 separate API calls, sending that massive payload once to generate the quality summary and then sending the exact same payload a second time to generate the coaching summary, you have instantly doubled your token costs.
Oh, wow. Yeah.
When you are processing tens of thousands of support tickets every day, that architectural inefficiency will hemorrhage money.
Not to mention the operational risk of the model contradicting itself across two separate calls.
That is the secondary and perhaps more critical risk. In two isolated generation events, the stochastic nature of the LLM might cause it to say, your empathy was excellent in the quality summary, but then hallucinate in the coaching summary and suggest you need to work on your tone and empathy.
Which would just confuse the agent to no end.
Exactly. By engineering a single unified prompt window that generates both outputs simultaneously, they eliminate the risk of contradictory logic and they slash the compute costs in half, safely maintaining that strict $1 per case budget constraint.
That's incredibly smart. Now, here's where it gets really interesting. The document goes into phenomenal detail about how they actually selected GPT 4.1 Mini for the specific narration task. They didn't just guess, they ran extensive LLM experiments.
Yes, the testing phase was rigorous.
They set up a testing arena with Gemini 3 Flash Preview, GPT 5.2, and Gemini 2.5 Flash. And they evaluated the outputs using an automated testing framework called OPIC.
And this section of the text is a complete masterclass in the dangers of relying entirely on automated benchmarking. OPIC measures specific generative metrics, answer relevance, hallucination rates, and moderation compliance.
Right. And when you look at the raw data in the source, Gemini 2.5 Flash actually swept the board. It scored the highest on relevance, the lowest on hallucination, and the best on moderation.
It looked like a perfect score.
So, open and shut case, right. If you are an executive just looking at a dashboard, the decision is obvious. Gemini 2.5 Flash is the gold medalist. You pick them, sign the contract, and deploy it to production.
And if you did that, your system would be operationally useless within a week.
Wait, really? Why?
Because the engineering team did not stop at the automated metrics. They instituted a rigorous qualitative human review of the generated narratives. Real people sat down and read the paragraphs the models were spitting out.
And what did they find?
What they discovered was that despite winning the numerical benchmarks, Gemini 2.5 Flash exhibited catastrophic failure modes in practical application.
What does a catastrophic failure mode look like in this context? If the number said it was highly relevant and wasn't hallucinating facts, what was it doing wrong?
The qualitative review exposed 4 distinct critical failures. The first was generic reasoning. The model would state the final score, but it wouldn't connect the score to the specific actions the agent took.
It failed to explain the why.
Exactly, which makes the feedback completely useless for coaching. Second, it suffered from severe persona inconsistencies.
How so? Like, what does that mean?
Within a single paragraph, the model would violently shift its perspective. It would start by addressing the agent directly, saying, "You did a great job acknowledging the issue." But in the very next sentence, it would shift to a third-person robotic overview, stating, "The agent subsequently failed to provide a resolution."
Oh man, it sounds like the system is having an identity crisis mid-sentence.
It was jarring and deeply alienating for an employee trying to read their performance review.
That destroys the illusion of a helpful coaching assistant. What were the other 2 failures?
The third was something we touched on earlier, hallucinating trends. When an agent was relatively new and had an empty historical context window, rather than simply stating no historical data available, the model would confidently invent past performance issues just to have something to say.
It just hates silence.
It really does. The fourth failure was generating unsupported knowledge base recommendations. It would tell the agent, you should review Article 402 on password resets, even if the ticket had absolutely nothing to do with passwords, and Article 402 wasn't mentioned anywhere in the underlying classification data.
Wow. It is a stunning indictment of the entire concept of using AI to judge AI. The automated OPIC metrics completely missed these deeply structural psychological flaws in the generated text.
You absolutely must have a human in the loop reading the output.
So if the statistical winner was rejected, how did they find the right model?
They pivoted heavily into advanced prompt engineering. They utilized a technique called meta-prompting, where they actually used the massive frontier-level models, GPT 5.2 and Gemini 3.1 Pro, to analyze and rewrite their original prompt instructions.
They essentially asked the supercomputers to help them write a more rigorous set of rules for the smaller computers.
Exactly. This created a highly optimized version 2 prompt.
And when they ran the tests again with the newly optimized instructions,
The landscape shifted entirely. With the strict constraints of the version 2 prompt, A smaller, highly efficient model, GPT 4.1 Mini, emerged as the undisputed champion.
Oh, nice.
It eliminated the persona inconsistencies, it provided highly specific reasoning tied directly to the Python scores, and it achieved the absolute lowest hallucination rates across the board. Furthermore, because it was a smaller model, its compute costs easily fit within their strict production budget.
A smaller, properly constrained model outperforming the massive, unconstrained giant. It's a perfect encapsulation of the entire multi-model philosophy.
It really is.
But there is a side experiment detailed in the text that I think is honestly the most terrifying and illuminating part of this entire deep dive. They wanted to see what would happen if they broke their own rule.
Ah, yes.
They wanted to test exactly what would happen if they did allow a generative LLM to attempt a discriminative task. We called it the confabulation experiment.
Yes, this is a vital piece of architectural research.
Yeah.
They took a highly complex, nuanced support ticket and fed it into the Gemini models. They asked the LLM to classify just one specific behavior: successful resolution. Did the agent fix the problem?
Okay. And what was the actual answer?
The ground truth, verified by human experts, was negative. The agent fundamentally failed to resolve the customer's core issue.
And what did the massive neural network decide?
It misclassified it entirely.
Right.
Across every single test run, the model labeled the resolution as positive. It completely failed the basic discriminative task of understanding the outcome.
It got it wrong every time.
Every time. But the failure isn't the most alarming part. The alarming part is what the model did next.
What did it do?
It generated a highly articulate, multi-paragraph explanation vigorously defending its incorrect classification.
It confidently argued a completely false reality.
It did. It pulled specific quotes from the text, wove them into a coherent narrative, and provided deeply convincing logic for why the case was a massive success, even though the ultimate conclusion was entirely backward.
Confident, articulate, and dead wrong. Which brings us to the psychological concept of confabulation.
Exactly. In human neuroscience and psychology, confabulation is a fascinating memory disorder. It is defined as the production of fabricated, distorted, or misinterpreted memories about oneself or the world.
But it's not lying, right?
Crucially, no. It occurs without any conscious intention to deceive. The patient isn't lying. Their brain simply encounters a gap in its memory, and it instinctively generates a plausible-sounding story to fill the void, protecting the coherence of their reality.
And large language models do the exact same thing. They don't possess an internal model of objective truth. Their primary foundational directive is simply to predict the next token to create a plausible, structurally sound narrative.
Building on that, if a model takes a wrong turn at the classification stage, if it decides the ticket is positive, its predictive engine will then use its immense linguistic power to justify that wrong turn. It will align all subsequent generated text to support its initial flawed premise.
Which provides the ultimate, undeniable proof of why generative AI should only narrate and never classify.
Never.
If you allow an LLM to evaluate the data and it makes a mistake, it will essentially gaslight your QA team into believing it was right. Its explanation will be so convincing that a human reviewer might actually second-guess their own judgment.
That's very persuasive.
But if Layer 3 Python scripts do the classification and the Python outputs a rigid, unchangeable score, failure, the LLM accepts that failure as absolute reality. It is forced to narrate the failure.
The deterministic Python layer creates a mathematical boundary of truth that the generative model simply cannot cross. It is the cage that keeps the LLM aligned with reality.
That's such a great image, the cage of truth. The level of engineering discipline required to build this system is just incredible. But to truly understand why this depth of precision isn't just, an interesting technical exercise, but an existential requirement for businesses right now, we need to zoom out.
We need to look at the market.
Exactly. The source text places AutoQA within the broader context of the contact center as a service industry, the CTS wars. And it points to a very specific pivotal date in the market, March 10th, 2026.
That date marks a massive shift in the enterprise landscape. It was the launch of Agentforce Contact Center by Salesforce.
And the context here is vital because 3 years prior, back in 2023, Salesforce was actively promising the market that they had absolutely no intention of building a contact center.
They were very clear about that.
They told everyone they were perfectly happy being the CRM, the central database, holding all the customer records, and they would happily partner with voice vendors like Genesys or Amazon Connect to handle the actual phone calls. But then, in 2026, they completely reversed course, launched their own contact center, and called it an iPhone moment. Why the massive pivot? What forced their hand?
It comes down to a fundamental law of enterprise architecture called data gravity and the urgent need to eliminate what the industry refers to as the seam.
The seam?
Yes. In a traditional legacy setup, you have your voice and routing infrastructure living in one system, say Genesis, and you have your rich customer history, purchase data, and account details living in a completely separate system, Salesforce. There is an integration seam between them. Data has to be passed back and forth.
Which was fine when human beings were running the show. A human agent can look at a screen, see that a phone call is coming in from Genesis, quickly glance at the Salesforce window, realize the customer just bought a defective product yesterday, and synthesize that context in their head before even saying hello.
Exactly. Humans are incredible at bridging context gaps. But when you deploy autonomous AI agents to handle customer interactions at scale, that integration seam becomes a massive system-breaking liability. AI context degrades violently across the gap.
How bad does it get?
Well, if an autonomous voice bot is operating inside Genesis, and there is even a millisecond of latency or an incomplete data sync with Salesforce, the AI will answer the phone entirely blind to the fact that the customer is already furious about yesterday's purchase.
Oh, that's a nightmare. The AI sounds incredibly stupid. It asks the customer to repeat information they already provided, and the customer experience completely implodes.
Salesforce recognized that for autonomous AI to truly function, it requires instantaneous, unimpeded, zero-latency access to the entire data model simultaneously. The only way to achieve that was to eliminate the seam entirely. So they built the contact center natively inside the CRM.
Smart.
As the analysis in the source astutely points out, Agentforce Contact Center is essentially a platform sovereignty play disguised as a telephony product. Every single voice call, text message, and email now flows directly into the Salesforce ecosystem. It immediately becomes structured data that trains their proprietary AI models, informs their internal routing, and feeds the CRM, creating a closed-loop system of immense data gravity.
It is the ultimate transition from the old paradigm of AI in the contact center, where AI is just a helpful little widget summarizing notes for a human agent, to the new reality of AI as the contact center.
Yes, the autonomous agent is the primary worker.
Right. It's the first line of defense, and human beings are relegated to being escalation handlers for the edge cases. So if we accept that AI as the contact center is the new reality, what does that mean for a tool like SupportLogic and AutoQA? If Salesforce is building the ultimate all-in-one AI fortress, where does a specialized evaluation tool fit into the puzzle?
It transforms AutoQA from a niche compliance tool into the most strategically critical feature in the entire operational technology stack. We have to rethink what QA actually is.
How so?
Well, in a human-driven contact center, QA was mostly a retrospective compliance exercise. You sampled maybe 2% of calls to make sure agents weren't swearing at customers or breaking basic legal disclosures.
Right, mostly box checking.
But when AI agents are operating autonomously at massive scale, handling thousands of end-to-end interactions in an hour without a human ever seeing them, QA fundamentally changes, becomes your only operational control surface.
Because the entire premise of autonomous AI is scale. If you deploy an AI agent to handle 10,000 routine password resets a day, you cannot hire 1,000 human managers to sit there and double-check every single AI interaction.
Exactly. If you have to do that, you have defeated the entire economic purpose of automation.
You're just paying humans to watch robots.
Yes, you are flying completely blind at Moth 3. If your brand new AI agent inadvertently starts ignoring expressions of deep customer frustration, or if its language model starts hallucinating incorrect return policies, or if it entirely misses the subtle cues that an issue needs to be escalated to a human, the damage scales instantly. You cannot afford to wait for a viral PR disaster on social media, or a massive regulatory fine, or a plummeting net promoter score at the end of the quarter to realize your AI is broken. Automated QA, operating at the extreme depth and multi-model precision that SupportLogic provides, is no longer an optional add-on. It is the core infrastructure of trust required to let AI operate autonomously.
And that brings us perfectly to the cautionary tale highlighted in the text. There is a deeply revealing anecdote from a CX Today report about a major supermarket chain.
Oh, this is a great example.
They realized they needed to modernize, so they went out and bought a massive 7-figure bundle from a leading CKS provider. They looked at the feature list, they saw a box checked next to includes AutoQA, and they just assumed they recovered.
And the reality of what they bought was a harsh awakening. When they actually deployed the system into their live environment, they discovered that the built-in bundled QA met only 15% of their actual operational needs.
15%. That is a staggering failure of expectations. Why was it so completely ineffective?
Because the bundled tool was a shallow wrapper. It was a superficial, LLM-based checkbox feature designed by the vendor to close a massive enterprise deal, not a precision instrument designed to govern the complex nuances of autonomous AI and human performance.
Just a shiny wrapper.
Exactly. When you analyze the current market differentiation giants like NICE, Genesys, Microsoft, Zendesk, they are all racing to bundle generic AI tools together to claim completeness of vision. But a shallow QA tool will instantly fracture when put under the extreme stress and volume of autonomous agentic AI.
It's the Swiss Army knife versus the master carpenter all over again. The supermarket bought the Swiss Army knife and then realized they couldn't build the house.
That's exactly what happened.
SupportLogic's highly decoupled, deep, multi-model moat is the specific architecture that enterprise leaders actually need. If you are going to trust a machine to talk directly to your most valuable customers, you require an evaluation system that can detect the microscopic acoustic tonality of anger in 3-second intervals. You require a system that evaluates SLA adherence with deterministic Python math. You need the deep signal, not a generic summary.
The technical architecture we have spent this time deconstructing isn't just an interesting academic approach to building software. The architecture is the product's primary competitive advantage. The absolute mathematical and auditable defensibility of the score is the entire value proposition.
So if you are an enterprise leader navigating this massive transition, the question you have to answer tomorrow morning is not whether you are going to deploy AI agents. That is already a foregone conclusion.
The market and the technology curve have decided that for you.
Exactly. The existential question you need to be asking yourself and your engineering teams right now is, how will I know the exact moment my AI agents begin underperforming, and exactly how fast will I know it?
That's the real question.
If your strategy relies on waiting for the customer satisfaction surveys to roll in next month, you are already operationally dead in the water.
The required capability is a system that understands the precise millisecond an interaction degrades and can provide an instantaneous, mathematically sound, and audibly verified explanation of exactly why it failed.
We have journeyed through an immense amount of technical and strategic territory today. We began by exposing the seductive trap of the LLM wrapper, that really dangerous assumption that a single, massive, generative AI possesses the precision required for enterprise evaluation.
It's an easy trap to fall into.
It is. We broke down the 6 fatal flaws of that approach, from its deaf modality and inability to do basic math, to its toxic hallucinations, inconsistent scoring, budget-destroying compute costs, and its dangerous asymmetry regarding false positive.
And from there, we explored the elegance and absolute necessity of the multi-model architecture. We saw how specialized tools divide and conquer the complexity.
Right, utilizing dedicated Vertex AI endpoints to isolate and detect raw acoustic anger in microchunk.
Deploying discriminative models like Roberta for rigorous binary text classification. And perhaps the most vital lesson in engineering discipline, relying on transparent, auditable, spacey rules for rigid linguistic patterns, where predictive AI is completely unnecessary.
We then explored the absolute necessity of deterministic scoring, the guiding principle of banishing neural networks from the grading process. By keeping the scoring math completely isolated in Python scripts, the system achieves perfect mathematical certainty and unlocks a modular architecture that allows every single layer to be independently upgraded without shattering the underlying logic.
And finally, we saw the proper, constrained role of generative AI acting purely as a synthesizer and narrator, operating in a highly efficient single-pass framework that slashes token costs and prevents operational confabulation.
So many moving parts, but they all fit together perfectly.
A critical takeaway from this architectural breakdown is that system cost and context completeness cannot be treated as afterthoughts. You cannot build a massive, inefficient system and try to bolt on cost savings later.
It doesn't work.
It doesn't. Building for extreme efficiency from day one, designing a system that deliberately orchestrates smaller models, explicit rules, and single-pass generative prompts to stay well under that $1 per case threshold forces a level of engineering discipline that inherently creates a vastly superior, more robust, and more accurate product. In enterprise architecture, severe constraint breeds ultimate precision.
It really is the profound difference between trying to build a skyscraper with a generic multi-tool and arriving at the job site with a masterfully engineered set of specialized instruments. But before we finish our deep dive today, I want to leave you with one final, deeply provocative concept drawn from the very margins of the SupportLogic document.
Oh, this is a good one.
It is a reality check that forces us to question the foundation of everything we build. The text briefly outlines a phenomenon known as the gold standard fallacy.
This is perhaps the most sobering realization in the entire field of machine learning.
When the engineering team at SupportLogic was rigorously auditing their evaluation data, the core data sets they used to train, test, and judge the accuracy of their own multi-model system, they made a startling discovery.
They found that the human-labeled ground truth, the data meticulously scored by experienced human QA managers, actually contained false positives and inherent inaccuracies.
The human experts had made mistakes.
They had.
But historically, the entire software industry treats human-labeled data as the absolute unquestionable gold standard. It leaves us staring at a deeply unsettling question. If the human data we use to train, constrain, and judge our artificial intelligence is inherently flawed, how much of our critical enterprise infrastructure right now is operating at massive scale, trained on perfectly confident human mistakes?
It shatters the illusion of perfect objectivity. We construct these incredibly elaborate, multi-layered, deterministic architectures in a desperate pursuit of absolute precision, but the foundational bedrock we build them on is human data. And human data is inherently noisy and flawed.
We're all just a little stochastic.
We are. It means that deploying the system is only the first step. The architecture demands constant, vigilant, and relentless auditing of our own underlying assumptions.
It's a fascinating, almost terrifying thought. You desperately want the machines read out to be flawless, but the deeper you look into the code, the more you realize the ghost in the machine is just us. Thank you for joining us on this deep dive into the architecture of the future. Keep questioning the wrapper, and we will catch you next time.